And in today's video I'm going to show you very simple circuit so you can build let's say a car turn signal to blink this light bulb using a LED as a flasher. And I'm using this kind of LED, which is self-blinking LED, and you can easily find on the internet. They are very cheap. And for this project I'm using only the resistor of 470 ohms for the blinking LED and one small light bulb, and the transistor is BD681. It's a 4 ampere N-pen, Darlington N-pen transistor. And the first leg is emitter, collector and base. Remember that. Let's build the circuit now. That's it, I'm finished. 40 seconds with only using 1, 2, 3 and this is 4 components to make a blinking light bulb using the LED. You can use this circuit for your car turning signal. Let's power it up. It needs from 4 volts to 6 volts maximum, because the light bulb is 6 volts, and if you want to use it for 12 volts that is not a problem. On the emitter go negative and here go positive. Take a look the simplicity of this circuit. Using one LED, one blinking LED, we make to flash the light bulb using a transistor and that LED. This is a cool and I like it because it's simple. 3 components only. 1, 2, 3 to blink the light bulb. Wow! I don't think so that I need to show you the schematic. It's simple. Only one N-pen transistor, the LED and the resistor. The LED through the resistor is connected on the base. The collector of the transistor is output for the bulb, and on emitter we connect the negative power supply. Positive go to the light bulb, and on the resistor, in my case I'm using 470 ohms for the LED, and it's working perfect. I like it. Please give a like, share the video and subscribe to my channel. Using this N-pen transistor that can handle with maximum 6 amperes of load, and it doesn't cost very much, you can make an interesting circuit. You can buy 10 pieces of TAP41C N-pen transistor from AliExpress for 86 cents, and from eBay you can find it for around $1.80 or $2 for 10 pieces of this transistor. It's very popular and very used N-pen transistor. As I said, it can handle up to 6 amperes of load, and here it is a very simple circuit diagram of how to make an automatic on-off light, or to use this circuit for your street light. It uses only 3 components: the transistor, the photoresistor or the LDR, and one resistor of 120 kilo ohms. The LED can be any type of LED, around from 3 volts and maximum to 12 volts. I'm gonna use a 12 volt array of LEDs. This circuit is working from 6 maximum I think to 24 volts, and the transistor pinout is base, collector and emitter. On emitter is negative power supply. The collector is output for the LED. On base is connected 120 kilo ohm resistor going to the positive power supply, and the photoresistor is connected between base and emitter. That's it. As I told you, you will need only one N-pen transistor. In this case I'm using TIP41C. It's a 6 amperes transistor, one resistor of 120 kilo ohm. This is a photoresistor LDR, and I'm using this LED light which can work on 12 volts. So this circuit is for 12 volts, but you can run it from around 6 volts, maximum I think 20 or 24 volts. Okay, let's now solder all the components, all 3 of them. Finish it. Simple as that. 3 components, automatic on-off light. You can use this for street light, and this is the simplest way how to make it. I'm gonna try it. As I said, I'm using 12 volts. Set my power supply to 12 volts. On this point go 12 volts, and on the emitter of the transistor go negative. And it's not working. Why? Because there is a light. The photoresistor picking up the light, and it's working. Just to kill the studio lights. Working, not working. All right. One more time. LEDs turn it on. When it detects a light, LEDs turn it off. And you can use this circuit with this transistor that can handle maximum up to 6 amperes. You can put some high power LEDs and use the transistor maximum. It's very simple, the simplest automatic on-off light. Alright. Hello Hacktubers and welcome back to my welcome back to my channel. Let's start the video now. You need only 7 components to make this LED driver. Simple LED driver. 1, 2, 3, 4, 5, 6, 7. From eBay. Couple of years ago I ordered 100 solar LED drivers, and this model is 5252F, the solar garden LED driver. Step up voltage. And basically almost in every solar garden light there is this integrated chip, and I have made a new circuit for my blinking LED, because the circuit that comes with the ordinary solar garden lights, the LED blink type will not work. So I needed to modify, add few components like 470 ohm resistor, one diode 4007, this is 150 millihenries inductor, the integrated chip 5252, 10 nanofarads capacitor and 100 nanofarads also capacitor. This blue LED, it have built-in chip, so it can blinks, and it works on 3 volts, but using the step up integrated chip 5252 it will increase the voltage so the LED work properly. And here it is, my experiment, my testing circuit, where all 7 components are soldered, and you can see that the red LED is blinking and is working properly on 1.2 volts rechargeable battery, which is good and tested. The first 2 components that I'm gonna solder are the inductor and the 10 nanofarads capacitor. Both of them are connected in parallel. I'm gonna solder first these components. Next I'm gonna solder the diode together with the 470 ohm resistor, and the last is the LED, and in parallel with the LED I soldered the 100 nanofarads capacitor. You can see that the circuit is finished, and it's more compact than my testing circuit. So now I'm gonna explain the points. We have 3 points. The first point is the ground. The second point is pin number 1 of the integrated chip 5252 is for the solar panel, for the positive side for the solar panel, and the third point is positive for the battery. On these points I'm gonna connect my solar panel and my rechargeable battery. And now you can see that on my power supply I'm using 0.9 volts, and when I hook up the alligator clips the circuit starts working, which is good, and it pulls out about 3 to 5 milliamperes. That is great. That was my point, to make a circuit that will consume less power. And here it is. My circuit is finished. I have soldering all the components, adding the rechargeable battery 1.2 volts. This battery have 2000 milliamperes. It will last a super long time with the self-blinking LED circuit. The solar panel will give around, I don't know, 20 milliamperes to charge the battery. And to mention one more time, the circuit is working from 0.9 volts up to 1.2 volt maximum, and it will pull about 3 to 7 milliamperes, depends on how much the battery is charged. I made this circuit because I wanted to drive a LED, a self-blinking LED, adding few components, and if you add just ordinary LED will work, but if you add A self-blinking LED will not work if you do not add these electronic components like on the circuit diagram. Now I'm gonna turn off the studio lights and to see how it works, this self-blinking LED on 1.2 volts, because the LED, as you know, it's working on 3 volts, but with the integrated chip 5252, that is a step up voltage converter for solar garden lights, you can see that the blue LED working great. And the last thing that I want to show you is that I'm gonna use this 8mm LED, which is ordinary, not self-blinking, but when I hook up in parallel with the red LED, just look, the blue LED start blinking too. Why? The red LED is self-blinking, the blue is ordinary, but when it's connected in parallel, they blink both. Why? Comment below what you think. This is weird. Wireless power energy. In today's video, I'm gonna make this Lamborghini Hot Wheel toy to light up with wireless energy. Let's start the video. So to explain how this works, we have the receiver coil and this is the transmitter coil. The receiver coil is a simple copper wire wound on some kind of object. In this case, the coil is wounded on the LED and the transmitter is this circuit. I have made several videos about mini wireless energy circuit. Here I have positive and negative terminals for powering the circuit, and here it is the circuit that consists out of one NPN transistor. In my case I'm using BC337, or you can use any else NPN transistor, 1 kilo ohm resistor. Here it is the coil and it's working on 1.5 volts. To mention, if you make a wireless receiver coil out of couple of loops of solid copper wire, you can use wireless charger for smartphones. And if you make one of these and place it on the charger, you will see that it is blinking. That way is working the charger, because this coil is without electronics and picking up only the signals. Okay, if you can't make this circuit, which is wireless transmitter circuit, you can use your wireless phone charger. As I said at the beginning of the video, I'm gonna make this Hot Wheel toy to light up with the wireless energy, and I have already disassembled the toy and place two LEDs on top and inside, one blue and one red LED. And here where is marked, I'm gonna place my coil out of solid copper wire. And here it is, my very popular mini Hot Wheel DeLorean car, and you can see that the coil is right here. I have around 30 loops of solid copper wire, and when you place it on the wireless charger, it will blink like this, which is cool. Also, I'm gonna do that on this Lamborghini Hot Wheels. I found a perfect wooden block that fit on my Hot Wheel toy, so I can build the wireless coil, and I'm using a copper wire from a transformer. You can find it easy in some kind of radio, old radio, and pull out the transformer and you can find the copper wire, and I'm gonna wound on the wooden block that fit on my place on the Hot Wheel toy. As I said, on this small wooden block that is 1.5 centimeters by 1.5 centimeters, I'm gonna make 30 loops of this solid copper wire. After making 30 loops, you should get something like this with start and end point of the copper wire. Now I'm gonna pull it out of the wooden block. Be careful. Okay. And here it is, the receiver coil for the Lamborghini Hot Wheel toy. I'm gonna place it right here. I have placed two LEDs that are connected in parallel, and I'm gonna solder the copper wires from the coil on the positive and negative leg of the LEDs. Now the coil is connected in parallel with the positive and negative leg of the LEDs. It's working! Beautiful! Just to turn off the lights. Don't forget to support my work with giving a like, share and subscribe. And let's continue with the project. This is the simplest receiver coil made out of copper wire, and directly the LEDs are soldered on that coil. And when I place it on my wireless ladder, right away it's light up. Here it is, the DeLorean. I have epoxy resin Lego man. Just to turn off the light so you can see better. They look beautiful. And you can also make your own wireless power energy gadgets like mine. When you remove it from the wireless charger, not working, place it on the pad. Beautiful light up Hot Wheels toy. Alright. I also made a receiver circuit in epoxy resin, and in this model have couple of LEDs this way. Take a look, beautiful. Turned out pretty cool desktop gadget, adding wireless power energy to the Hot Wheel toy. And it's working, and it's amazing. That was all for today's video. Thank you for watching. Please like, share and subscribe. See ya!